Hey everybody, chemistry yet again today. This is a recap of what we did yesterday and adds just a little bit, so make sure you watch the entire video. Today is writing chemical equations, and we're building on the principles that we learned yesterday in terms of writing chemical equations. Now, here on the first screen here, you can see I have some steps numbered. We have 1, 2, and 3. These are the 3 steps you need to take every time you are writing a chemical equation. So make sure you take down the steps. A few are different, especially, number 2 is the main one that's different from what we did yesterday, just something we're adding today now that we kind of have a feel for writing chemical equations. So, step 1, whenever we are given a written chemical equation. So by written chemical equation, I'm thinking one like this, where it's like written out in words and we got to translate it into symbols. The first step you take is to translate all the words into symbols. So like if it said lead, you would convert that to Pb. If it said carbon, you'd convert that to C. So you go through first and you convert every single word into a symbol. That includes words like make or produce. Remember, if you are saying produce or make, you are translating that into an arrow. If it says and, plus, or added, or something similar to that, you are converting that to an addition sign. So that's the first step, is translating all of our words into symbols. Do that first every time. Don't try to do more than that for a first step. Step number 2, this is something we're adding to yesterday. So a few times yesterday you saw examples where we ended up with an element by itself. Like it would say something like chlorine plus calcium bromide leads to the formation of bromine and calcium chloride. So we end up with bromine all by itself on the product side. Anytime any one of these 7 elements ends up by itself, you have to add a subscript of 2. Now I know these aren't subscripts because Notebook wouldn't let me put a subscript in here, but it should be a little subscript down here. The 2 should be right there, so it should be H2, N2, O2, etc. These 7 elements are the only ones you have to worry about that for. So anytime you have hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, or iodine by itself in a reaction, you have to add the 2. And usually it'll say like bromine gas or nitrogen gas, something like that, and that'll help give it away. But if you take these down, you shouldn't have an issue with it because you're doing this in order. So every single question you're like, okay, I'm going to translate everything into symbols. Then I'm going to check to see if any of these elements need a subscript of 2. Do I have a hydrogen? Do I have a nitrogen? Etc. etc. If you don't, then you move on. If you do, then you just add that little subscript of 2 and you can move on. Now, you only do this if it's not in a compound. So if it's like dihydrogen monoxide, if it's water, obviously, well, you still end up with a 2. That's a bad example. But if it's like, like calcium bromide or something like that, you don't have to add the 2. You only add the 2 every time if it's in or if it's by itself. Only add the 2 if it is totally by itself. So just be aware of that. You need to check for that every single time that you're adding the 2 if it's by itself, only if it's not in a compound. And then finally, the last thing you do after you have done all of that, you've translated everything into symbols, you've checked to see if you had any of these, is you look at the compounds and you decide if the charges need to be crisscrossed. So if it's an ionic compound, meaning a metal and a nonmetal, you got to take those charges like calcium plus 2, bromine minus 1, and you got to crisscross them to make sure it balances out to CaBr2. So we talked about crisscrossing a lot yesterday because that's something a lot of people had forgotten. Make sure that you crisscross your compounds when necessary. We're going to do a lot of examples today. Okay, just last thing, just to add to the very end, some other vocab words. The left side of an equation, so right here would be calcium and water. Those right there are considered the reactants because they are reacting together. So anything on the left side of an equation is considered the reactants. So I would write this equation out and label this left side reactants. Anything on the right side of an equation are considered the products because they are being produced from this reaction. So reactants on the left side are reacting to produce the products right here. So anytime it comes after the arrow or after the word produces, you know those are going to be the products. Now, I'm going to have you do one practice problem before you move on. So look at this here. It's chlorine added to calcium bromide produces bromine gas, and calcium chloride. So do this one, and you can do this in your notebook. I would rather you do it in your notebook rather than writing it somewhere else. That way you have the example. So write this out. Write chlorine added to calcium bromide produces bromine gas and calcium chloride. And then below it, go through our process. So first, translate all words into symbols. Then check to see if the elements need a subscript of 2. Then check to see if the compounds need charges crisscross. So take a minute. Write that down, pause the video, and I'm going to show you the answer. So pause the video, write that down. Okay, so hopefully you paused the video, wrote that down. We're going to go through the process really quick so you can see the answer and you don't have to wait for me to come over. So first thing I do is translate everything into symbols. So I go chlorine is Cl added. I know that's a positive sign or an addition sign. Added to calcium bromide. So I look at my periodic table. I see calcium is Ca, bromine is Br. Buy your homecoming tickets for the game. Come on into the main office. Come into the main office if you want to buy your homecoming game tickets. Okay, onward and upward. Calcium bromide, CaBr, and produces. That's another key word for me, so I know that's arrow. Produces bromine, so I know that's Br, and is an addition sign, calcium chloride. Okay, am I done? No, I'm not done. Look back at my steps. After that, I've translated everything, all the words into symbols. Now I need to check and see if there's any elements that need a 2. So do I have any of these by themselves? Let's find out. Yes, I do. I have 2 of them by themselves. I have Cl, so I need to add a 2 to that, and I have bromine, so I need to add a 2 to that. See, I did that, just check, and then add the 2. Okay, am I done now? No, I'm not. I need to check to see if the compounds need charges crisscross. So I have 2 compounds here. I have this one and this one. I see that calcium and bromine, that's ionic, calcium and chloride, also ionic, so I do need to crisscross the charges. Bromine has a charge of 1-, calcium of 2+, so I bring the 2 down here, the 1 down here, so I end up with CaBr2. And then over here, calcium again 2+, chlorine again 1-, so I'll take the 2 from calcium and bring it down here, the 1 from chlorine and bring it down here. So that should be your final answer right there. Cl2 plus CaBr2 produces Br2 plus CaCl2. That should be your answer. Hopefully you got that right. And now as soon as this video is over, you can move on to this. It's writing chemical equations. I know it's a lot, but we really need a lot of practice at this to get consistent. You can work with your partner on that to check each other off, but we are going to move to this now. You have about 20 minutes to do that, and then we are going to move forward. So if you have any questions, ask. Otherwise, good luck.